Welcome to this session on maths practice videos. I've taken these questions from the Shanghai Maths Project practice book 6B, and the questions are based on equations and algebra. So let's get started. At a school, there are 237 pupils in year 6, which is 24 pupils fewer than 1.5 times the number of pupils in year 5. So how many pupils are there in year 5? So they have given us the number of pupils in year 6, and then we have to form an equation which relates the year 5 and year 6 pupils. So that's in year 5 is x. So the number of pupils in year 6 will be 1.5 times the number of pupil and minus 24. So what we get is 1.5x minus 24, and that equals 237 because the number of pupils in year 6 is 237. So what solving for x, we get x equals 174. So the number of pupils in year 5, that's the question, and the answer is 174. The next question is: a clothing factory plans to make 1960 sets of clothes. It has made 620 sets, and the rest of the clothes should be made in 4 days. How many sets of clothes are to be made each day on an average? So how do we do this? So the total number of clothes it plans to make is given. Okay, now it has made 620 so far, and the rest of clothes should be made in 4 days. So we have to find how many are left, and then how long it will take us, and that number of clothes are made in 4 days. So on an average, how long would it take? So what I did is the sets of clothes left to make is 1960 minus 620, which gives me 1340. The maths is correct. Yes, it looks correct. So 1340 sets are to be made in 4 days on an average, that is each day it would be 1340 divided by 4. Okay, so 4 times 3, 12. 1, 6 is 1. Is that right? Wait. Is that correct? 4 times 3 is 12 and 1 13, and 4 times 3 is 12, 2, 5. So the answer is 335 sets, not 360 sets, as I mentioned earlier. So what we do is, so you can understand that for, is that right? Which is 12 and 1 13. Yeah, so we need to check. Yeah, okay, so that's right. The next one is: in a school table tennis team, the number of boys is 1.2 times the number of girls. There are 6 more boys than girls. How many boys and girls there in the table tennis team? So we have to assume one of these is x. You can do either way, and you have to form an equation because the number of boys is 1.5 times the number of girls. 1.5 times, not 1.5, sorry, 1.2 times. So it's 1.2x, and then more than that, so 1.2x plus 6. So here's what we have. So here's what we have: the number of girls is x. Okay, so the number of, number of girls is x. So they're saying that the 6 more boys than girls, So boys is x plus 6. The total number of boys and girls is x plus 6. That's right. So boys is 1.5 times the number of 1.2 times the number of girls. The number of boys is 1.2x. So if you do that, so boys is 1.2x plus x, or you could have just done this, 1.2x and related to this, made this equal. So we didn't have to do this, but it doesn't matter, this x gets, that's nullified, and we're left with x equals 30. Yeah, 1.2x, yeah, so 0.2, so yeah. So the number of girls is 30 and the number of boys is 36. Okay, so the next one is, you can do a check. Is it true? Boys 1.2 times, so 1.2 times 30 equals 36. So it is correct. It's always good to check. The next one I did is question 4. There are 3 kinds of fruit trees in an orchard. There are 360 apple trees, which is 40 trees more than pear trees. The pear trees are 20 fewer than twice the number of peach trees. How many peach trees are there in the orchard? So this is just a lot of trees, and more and less and less and more. So the thing to note is one of these has to be assumed as x. It makes it easier to work it out. So if we work work backwards, like the number of peach trees, and we say the peach trees is x, we are assuming that the number of peach trees is x. So the apple trees are given, which is 360, that's right, and which is 40 times more than the pear trees. So 43 is more than the pear trees. Mind you, it's not times, it's 3. So the number of pear trees is 360 minus 40 is 320. That's right. So the peach trees I've assumed is x. So my equation will be the pear trees. This part is the equation part. This is my equation part. The pear trees are 20 fewer than twice the number of peach trees. Okay, so here are your pear trees, 320. So 320 is 20 fewer, 20 less, minus 20, then twice the number of peach trees, so 2x. So we get, moving this to the left, I get 340 equals 2x. So x equals 170 peach trees. Okay. The next one is some oranges are shared among children. If each child is given 3 oranges, there are 18 oranges left. If each child is given 5 oranges, it's just enough, and so no more oranges are left. How many children are there? How many oranges are there in total? Okay, so some oranges are shared among children. Okay, so there are 2 things we don't know. Right, or we don't know the oranges, we don't know the children. So if the child is given 3 oranges, there are 18 oranges left. If each child is given 5 oranges, it is just enough, so that no more oranges are left. So the way I did this is, so I've assumed that the number of children is x. Okay, so if x is the number of children, if each child is given 5 oranges, the number of oranges is 5x. Okay, so we get 5x as the number of oranges, right? That is given to each child. Each child is given 5 oranges. Yeah, total number, yeah. That's the total, isn't it? So that's the total oranges. So if each child is given 3 oranges, then the total number of oranges will be 3x plus 18, because You need 18 more. There are 18 oranges left. So it'll be 3x plus 18. Now this are both oranges. So this is orange. This is orange. So 5x is 3x plus 18 is your equation, or 2x is 18, x is 9. So if x is 9, what is x? I said the number of children. Children equals 9, and the oranges equals 5 times 9 is 45. Okay, so that's your number of oranges because they've asked how many oranges are there, and that's 5 times 9. So the next one is Tom went to a bookshop with £100. He bought 4 storybooks at the price of £13 per book. Later he bought several graphic novels at £15 per book. He received £3 in change. How many novels did he buy? So the question is, he went with £100, right? Then he got 4 storybooks at the price of £13 per book. So if he got 4 storybooks at £13 a book, so how much did he spend? 4 times 13 is 52. So he has spent 52. So the money remaining is 100 minus 52. That's £48 is remaining. So now assume X is the number of the graphic novels he got. So the cost of those graphic novels is 3. He received £15 per book, so it's 15x, isn't it? One costs 15. So your equation is so 15x. He received £3 in change. The total is 100, okay, and remaining was 48. So 15x plus 3 is 48, okay, and 15x is 45, x is 3, so x is 3 means, so x is the number of graphic novels he got. So if he bought 3 graphic novels and they cost £15, so 3 times 15 is 45, and then he got £3 in change, so that's so you add 3 to it, you get 48, and yeah, so then it's 45, and then that's what you get, isn't it? So if you add them totally, you would get 52 and 45, 97, and then if you do plus 3 equals 100, so that is the total. So this is right. The next one is John has a bicycle. The perimeter of its front wheel is 250 centimeter and that of the rear wheel is 180 centimeter. John cycled from place A to place B. The rear wheel went round 1001 more times than the front wheel. Find the distance between place A and place B. Now this 1001 more times than the front wheel. So let us understand this question. So the wheel is 250 centimeters. So if you have this wheel and the perimeter or the circumference of the wheel is 250. So if this wheel was straight, this would be 250. Okay, so the distance it would cover in one round, starting from here, would be here. So this would go here, 250. So one time 250 centimeter will be one round, or one round, or one full complete circle, okay, going around the circle once. So 250 centimeter is what, that's how we have to find the distance. Now the next wheel, the first wheel is 250 centimeter. The second wheel, so one wheel is bigger, one is smaller. If you think of this cycle, you know, so back wheel is smaller, the front wheel is bigger. So the front wheel and the rear wheel, yeah. So then what do we have? What do we go about this? So the perimeter is 250 centimeter, which means it completes one round in 250 centimeter, right? And the perimeter for 180 centimeter completes one round in 180 centimeter. So they let x be the number of rounds, the number of turns of the front wheel that I was doing. So this wheel, this one, so you have this. So this is so the number of turns of the rear wheel, I think, is x plus 100,001. So if that's the case, okay, that's how many more times it's gonna turn. So the distance the front wheel will cover is 250x. The distance the rear wheel, because both wheels will cover the same distance. So the distance of the rear wheel is 180 times x plus 1001. So because it's this many more times, okay. The word times there made me wonder if I should use a multiplication, but no, it's not that. It doesn't work with that. So this is what I've used. So it's time. Okay. So so if this is how many times it turns, x plus 1001. So this is the how many more times it will turn, and the 180 is the wheel perimeter, and we are multiplying it with that to get the distance. Okay, so the equation is, because the distance is the same, if you see what I mean, the distance covered by both wheels is the same. So if the distance is the same, that is why we have equating both sides. So we have 250x, which is the first one, okay, is equals to 180x, so plus this. So we are opening up the brackets here, we are removing the brackets, okay. So we're removing the brackets with 180 times x plus 180 times 1001, okay. So 70x, so this gets here, is 180 times 101, we get x equals 2574 centimeters. Oh god, what have I written? Look at me. So it's not kilometer, it's 2.574, not 2.574. I've gone mad. So it's 25.74 meter. This is a 25.74 meter, or 2574 centimeters. So that's the distance between A and B. Right, isn't it? Yeah, centimeters. So I get, yeah, that's what I got, 2574 centimeters, or 25.74 meters. Okay, the distance. So look at all these problems, and if you have any questions, you don't agree with something, please do leave a comment and I will get back to you. The next one in the meantime is number 8. Okay, the sum of the numbers number B, and number C is 112. Number A is 3 times number B. Number B is 8 more than number C. Find number A, B, and C. So this is very straightforward. So what I've done is here, so we know that the sum of the three numbers is 112. So I put in that. And next I have the each of the relation between the numbers. Number A is 3 times number B, so A is 3B. B is 8 more than number C, 8 plus C. So using 3 and 2, so if you do that to express one in terms of the other, so we get A is 3 times, which is 8 plus C, or A is 24 plus 3C. So then we use 3 and 4 in 1. So if you do that, it is 24 and 3C. This equation, and I name it number 5. Okay, so this is the final equation that we need. right? So we get solve for C, and we get C is 16, and from there we get A and B is this. So that's quite straightforward. The next question is 9, so which is saying car A and car B started traveling towards each other at the same time, okay, from two places 390 kilometers apart. After 5 hours, the two cars meet each other. If car A traveled 2 kilometers faster per hour than car B, then how many kilometers per hour did car A and B travel? Okay, so the approach to this question is first the distance is known. The two cars are 390 kilometers apart, and after 5 hours, the two cars meet each other. So they meet at some point. So if we look at this, so this is 390 kilometer, and after 5 hours maybe they meet at some point here, and when they meet, so how much distance did they cover? We don't know, but the total of that distance would be 390k. Okay, car A traveled 2 kilometers faster per hour than car B. Then how many kilometers? So that's the basis for the equation. If I look at the next one, I've done that. Speed of car B is this, speed of car A. So we know the speed. We assume x, speed of car A is x plus 2 kilometers faster. Distance after 5 hours would be 5x kilometer, because we know that speed equals distance divided by time. So distance equal to speed multiplied by time. So that's what we've done here. The speed multiplied by time, 5x kilometer. Distance car A has after 5 hours is 5 times x plus 2 kilometer. So after 5 hours, the distance covered by, it's the total distance, not the distance. The total distance covered by both cars, because if they meet someplace here, this distance plus distance is 390. So my equation is going to look like 5x plus 5 times x plus 2 is 390. So I get x is 38 kilometers. So the speed of car A is 38 plus 240, and car B is 38. The next question is Mary walks to school every day. If she walks 60 meters per minute, she will be there 6 minutes late. If she walks 80 meters per minute, she will be there 3 minutes early. If Mary wants to be there on time, how many meters should she walk per minute? So again, that's what we will do, something similar to what we did in the last question. We will assume that the time it takes Mary to reach school is x minutes. Okay, that's the time. So that's the time it takes. Now we know the speed is distance divided by time. Okay, so when she is walking at 60 meters per minute, if we do that speed, and distance we don't know, but time we know will be x plus 6 because she's x minutes. Should she reach x minutes is the actual distance, as x plus 6 when she's 6 minutes late. When she's 3 minutes early, it would be x minus 3. So in using the same formula, now since the distance is the same, we can form an equation. We can equate the two. So 60 times x plus 6 is 80 times x minus 3, and solving we get 20x is 360 plus 240, that's 600, so x is 30 minutes. So now we know that x is 30 minutes. So there's another part to the question. We have to find the speed This is the speed, how many meters per minute. So how do we find the speed? To find the speed, we will need the distance, and we do not know the distance. So there's a way to do it. What I thought we could do it by saying that if Mary, when Mary starts, say, when Mary is arriving late, right? She arrives in 30 plus 6 minutes. So in 36 minutes, to arrive in 36 minutes, the speed is 60 meter per minute. Okay, so in 36 minutes, so we use that, and we use, so 36 minutes is 60 meters per hour speed, then 1 minute should be 60 out of 36 meter per hour. So if the time is 30 minutes, then the speed has to be 60 out of 36 multiplied by 30. That gives me 50 meter per minute, and that is my answer. It is a bit complex, especially the last bit, but I thought I got this is the way we can do it. Of course, there are many ways you can solve a problem, and this may not be the easiest way to do it, and I'm sure you have lots of very clever ways to do it. So, but however, this will help. It will help people who are struggling a bit with these kinds of questions. They may not be a regular 11 plus question, but these are good to know if you are going for any specific exams for any schools. Yeah, good to know. And even without any exam in mind, it's good to know if you are interested in to pursue maths in higher maths. So it'll be good to be able to solve these. So thank you for your time. Thank you, and please click on subscribe if you find the video useful. And I also have a maths problem solving sessions online I do on Skype. So you can send me an email at mathsforeveryone@outlook.com if you're interested in the details. Thank you, and bye.